Okay, Assalamualaikum and good morning. Okay, can somebody respond to me whether you can hear me or not?
Yes, Doctor, can.
Doctor can.
Can you repeat that? Something wrong with my system. Testing. Hello?
I can hear you, Doctor.
Yes, Doctor.
Okay, okay. Wait, I have to set something first. Oh. Okay. Okay, so for today, we will learn about debugging. So basically, debugging is just to repair the code. So what we learn today, we will learn about understanding the syntax error and runtime error. And also, you also learn how to perform debugging. Okay, there are actually two types of error. Either it can be syntax error or runtime error. Okay, so syntax error is basically a typing error. So you forget, for example, you forget the open bracket, close bracket, maybe the variable is not correct, or maybe the variable name is not correct. Okay, that one is syntax error. Sorry, variable name is not here. Only the what call typing. Okay, it's just a typo. And another type is a runtime error. So this one occur when the program is running. Okay, and when it's running, is sometimes it's detect. For example, array size is not compatible. Okay, invalid operation. Okay, logic error or rounding error. So you have two types of error, and MATLAB has include a couple of tools that can help you to detect this type of error or bug. Okay. So we start with the syntax error. Okay, syntax error is basically a typing error. Okay. So you can see this type of error in the error bar and the error message. Okay, I think this one I already show you in chapter 6, input output. Okay, and program will not be executed until the error is clear. So you cannot run the program if you have syntax error. Okay. So I showed you before, you can see the error at the sidebar here. Okay. So when you look at the side here, you can see that syntax error message, syntax error bar that show the location of your error. Okay, if your error is okay, if this one is an example of the error, you're missing a bracket. So it will show in the box here, and also it will line as red. Okay, so if you look here, you move your cursor near to this code, okay, near to this number, the line, red line, so you can see what type of error is shown. So you know how to repair the error. So this is one of the MATLAB tool that you can use. Okay, this one runtime error is much more complicated. Okay. So what is runtime error? I showed you before is error because of the maybe incompatibility. Okay, means that the array size is not the same. Okay, if you use array operation or maybe if you use metric operation, the array size is not compatible. Okay. Okay, this one I said before is harder to fix. Because error will be detected by the MATLAB when the program is running. Okay, or sometimes it can be logical error or rounding error. Okay, so to detect this bug, okay, or error, okay, usually we use a repair the runtime error, because we have to run the program to detect this error, we use breakpoint. Okay, I show you before how to use breakpoint. It's basically at the side here, you just click at this location. Okay, this location. Okay, when you click it, it basically pause your program. Okay, when you press run, it will pause at the breakpoint. Okay, it will not run the breakpoint. Okay, for example, you put at the breakpoint at line 2, for example. So line 2 will not be run. Okay. So when you do a debugging or you use a breakpoint, you have this. Okay, you have continue, you have step in, you have step out. Okay, so basically continue is just you run the program until you find the next breakpoint. Okay, so that is the function of the continue button. Okay, and step is basically after you meet the breakpoint, is basically if you click this, it's just run one line. Okay, this one continue until the next line, until the next breakpoint, but this one will continue only run one line. And if you have a function, okay, if you call another function, okay, basically the breakpoint will not go to that function. Okay, it will just run the function and move on. But if you want to look inside the function, you can use this one. Okay, and if you want to go out of the function, you use step out. Okay, so if you want to stop debugging, of course, you stop with debugging. So if you look undefined variable, this is one type of error. You can try this with your MATLAB. This is a tutorial, you can try this. So you can see here, you set the data 3575. But when you run data 2 is equal to data 1, okay, so you get error, undefined data. So basically, your naming is different. So data and data A. Okay, let me. Okay, this one is data. This one is data. You have extra A. Okay, double A. So this one is called. This is a typing error. Okay. Another example here you can try is incompatible array size. So remember that when you want to plus, okay, a metric, the metric size needs to be the same. So if you see here, this one is 1 multiplied by 3, and this one is 1 multiplied by 2. So the metric dimension must agree. So if not agree means that you cannot run this program. So to repair this, either you can reduce this, okay, reduce it, or you can increase this, increase the size of the B metric. Okay, so try this in MATLAB. So for example, here I paste here. Okay, you will get the dimension not must agree error. So if I repair this, for example, I increase a number, for example 3, and then I run again the program. Oh, sorry. Okay, if I run again the program, you will get the answer C. Okay, it can run. So there is another error, okay, which is, we call it logical error. Okay, logic error. So program is execute completely, okay, the program can run, but the output is incorrect. Okay, there will be no error message, okay, because the program is assumed by the MATLAB is correct. Okay, it can run, but the problem is the answer is incorrect. So this one you have, that's why when you do a programming, you have to check it manually. Okay, you have to check whether the program produce the correct output or not. So this is the possible reason. Divide by 0, this one usually produce a infinity output. Okay, array operation mistake, array indexing mistake, okay, looping mistake, wrong decision statement, okay, maybe you flip the if else, data type mistake, okay, wrong operation or equation. So this one is much more difficult to determine the error, because this one MATLAB cannot help you. Okay, others error MATLAB can help you, but logic error you cannot you have to define it yourself. Okay, I give you example 8.3. Try this. Okay, if you run this, okay, I think you still not learning the control, okay, but this is just example. Okay, if this one is equals to 0, okay, you cannot just equals to infinity. Anything that divided by infinity is anything by divided by 0 is infinity. But in control, if you meet something like this, for example, s is equals to 0.2, 0.2 minus 0.2 is 0, so you get the answer infinity. You cannot do that. So basically, for example here, so we run the s, okay, 0.1 until 0.2. S, okay, this one is called a S domain, so frequency domain. Okay, there are time domain, so time domain you already know, but this one is S domain. Okay, you will learn this maybe in the semester 3. Okay, so let me erase this. So basically, when you run this, okay, you get the answer because all the programming is correct. But the problem is when s is equals to 0.2, yeah, okay, you get none, because when 0.2 and a is 0.2, so 0 divided by 0 is basically, for MATLAB, is none. Okay, is none. But if in the control, okay, in the control you cannot do that. So basically, in control you cannot say that when 0 divided by 0 is s is none. Okay, not available. The return should be negative 2.8. So this is a logic error. MATLAB see it as a correct answer, but the theory is not follow it. Okay, you don't follow the theory. So to do this, you have to program the repair yourself. Okay, so you can see here, you can insert this. When the s is equal to 0.2 and s equals to a, okay, you have to assume this formula. Okay, else you have to use the original formula. Okay, so basically this is a logical error. MATLAB cannot detect it, but you have to detect it yourself because it doesn't follow the correct answer. So as a result, this one, it will show negative 2.8 instead of a none. Okay, you cannot get none in this. Okay, so we move on to another logic example here. Okay, so if you can see here, if you do this metric, okay, y equals to x multiplied by 1 plus a, okay, this one is x, this one is a, so you will get this answer. Okay, if you write the program inside the MATLAB, you get the answer. But if you extract this, which means multiply this and multiply this, okay, you will rearrange the equation and you run the code, you get a different answer. Okay, so basically, MATLAB is just running the program. Okay, but logically, you cannot get the answer. Okay, the answer is wrong. So maybe you can run this and determine why this is wrong. You have to refer back to the metric. Okay, you have to remember back why metric cannot do something like this. Okay, if MATLAB see this, it will plus first and then multiply. Why? But if you extract it first, why we is not get the same answer? Okay, so this is another example of logical error. Okay, next is rounding error. Okay, before we continue, we have a 5-minute break. Okay, no worry, today class will be short. Okay. So in the meantime, check in your attendance. Okay, we continue with our study. Okay. Okay, this next part is much more tricky. Okay. So logical error will produce error output. Okay. Because of the logic. Okay. But rounding error, even your logic is correct, okay, your answer will be wrong. Okay, rounding error is basically the round number. Okay. For example, what it means by rounding error is that okay, this number, for example, 0.153. So fine. Okay, for example. But if you compare it with 0.13153, okay, because you round it to the certain decimal point, it will not be the same. Okay, it's basically something like this, but for MATLAB, it's much more smaller. Okay, something like 1, 2, 3, 4, 5, 6. Okay, at the end. Okay, so basically, the error is caused by the number at the end. Okay, maybe the multiply by 10 power of negative 3 for 12, for example. Okay, the number is very small, but it affects the programming of the MATLAB. So let's move on to this example. Okay, if you see this program, it's basically okay. Okay, you have a number from 0.1 until 0.2. Okay, and then you add number 0.01. Okay, each time the iteration. And when the number detects 0.15, okay, you have to display x is now 0.15. So basically that is the program. So when you run this, okay, actually when you run this, of course you will meet 0.15 because 0.1 until 0.2. In the middle, you will find that it will be 0.15. If you add each iteration, you add 0.01. Okay, so basically, logically, you will display this. Okay, but when you run the program, it will not display. Okay, so let me test this. So let me add here first. Okay, if I run this, x is null is equals to 0.15 was not found. Okay, if I check this, okay, so I run this, okay, so x is 0.11. Basically, it's already added. So run again 0.12. I run again, continue 0.13. Okay, if I use step, I remember that the breakpoint. So step is basically run 1 by 1. You can see the error, the green arrow. Okay. But if you click continue, it will run until the next breakpoint. Okay. So right now is x is equal to 0.14. Now x is 0.15. So you can see here, x right now is 0.15. So if x is equals to 0.15, okay, so right now it should run this, okay. Logically, it should run this. So I step it. So I step, but it skip this. Means that this condition is not true, even though x is 0.15, okay. So the condition is still not true, okay. This is because of the rounding error. So what we want to see is, this is what let's investigate what actually happened. So if I run this coding, okay, when I run this coding, you can see that at 0.15, okay, at 0.15, it is not 0, but actually 2.7 something, the power of -17. Okay. MATLAB assume the precision it is not 0. Okay, it's basically a very, very, very small number. So that's what happened here. So the logic cannot be, because you compare with 0.15, right? So but the number is actually 2.17556 exponential e negative 7. This one is basically due to the 8-bit. Okay. You recall back here, where is it? Okay, I don't have the slide. Okay, so basically because of the limitation of the variable. Okay. So sometimes you can find error because of the rounding. Okay. So for this one, you have to test it yourself. Okay. If your logic is correct, but you still get the wrong answer, means that there are some rounding error. Okay. How to repair this? Okay. So how to repair the rounding error? Basically, you just round the number. So you basically you just tell the MATLAB to ignore the very small decimal point. Okay, so this is the example. Okay, the original code. Okay, you cannot. Okay, so let me get my pen. So you have b is 1 until 100. Okay, you have x is here, and you want to run x from 0.1 here until 0.2 with the increase of this. Okay, so when you run this, okay, x is multiplied by 100. So remember that x is 0.1, but actually has some value at the back, okay, at the end. Okay, very, very small number at the end. When you multiply 100, means that x will become x is 0.1 multiplied 100 is basically 10. Okay, 10.0000000 something value at the end. Okay, basically is 10, but in MATLAB it assume it is 10 point something. So when you want to call the b value, okay, index from b value, remember the index needs to be integer. Okay, but the problem is it is not a real value. Okay, so that's why it said that the indices must be either real or positive integer or logic. That's why it become error, because it is not 10 but actually 10.0000 something. Okay, so to repair this problem you basically have to put round. Okay, so basically if you write round, it will round to the closest integer. So this is the solution, you just round it. Okay, let's have a look at the case study. Okay, load factor. Okay, so basically this case study is just to show you how to detect multiple error. Okay, we have logical error, we have syntax error, we have run error. Okay, so this is the case study. So basically you can see here you have a table, something like this, a table of, you have start time and end time, you have the load. Okay, how much load is used in what, and then you have the interval. Okay, how long that the load used, and then you have the energy. So energy, remember that is power multiplied by time, you get the energy. Okay, this one is kilowatt hour. Okay, this is watt and megawatt. This one is megawatt hour. This is hour. So basically you have this table. This is the manual calculation. So how to do this inside MATLAB with only this data? Okay, so I have to clear this first, and of course, because if you look here, the next slide, you see that the data is collected from the Excel file. So you have to create an Excel file first. Okay, and then you copy the data. So you see that the data is from B4 until D8. Okay, so B4 until D8. This one, the location of the data. So make sure you place the data inside that location. And the name of the file is this one. Okay. So you have to transfer the data. Okay. So you copy this. Okay, and so paste it here. So this is the data. So the data start from B4, which is this one, B4 until D8. Okay, so make sure your location is correct. Okay, and you have to save it. Okay, where is it? Okay, so you have to save the data according to the code. So the code is load factor. Make sure you copy this and paste this. So I rename it at the desktop. Okay, oh, I forget to close the file first. Okay, make sure you close the file. If not, you cannot change the name. Okay, and make sure the location, the directory is correct. Okay, remember when you run MATLAB, make sure the directory is correct. Now you can copy back the code. So I run this, copy. Okay, remember if you have error here, invalid character, move your mouse to that location, it will show the error. So this one, you just replace back the same thing. Okay. So if you run this, okay, you get a error message. Okay, invalid expression. Okay, line 9. So if you click here, it will go to line 9. Okay, so line 9, you have error. So you can see here, you have extra bracket. So you delete this. So you run again. So unrecognized variable 4 at line 4. So you click it. Okay, you click it, or you can go directly to line 4. You find the B4. So you can see here, the error is somewhere here. So if you remember, you need to add this. Okay. So you run again. Okay, there's still error. Where is the error? At line 8. So you click here, you go to line 8. Okay. So basically, incorrect dimension of metric. So if I run this, okay, you can see that, okay, P is long, something like this. Okay, and dt is somewhere like this. So remember, P multiplied by dt, okay, if you check back this, you cannot just you cannot multiply using array operation. Okay, metric operation. You have to use a array operation. So how to do array operation? You have to put dot. Okay, when you put dot, you run again. Okay, you get the answer. But the problem is, you can see here multiple answer. So basically, if you look back the slide here, okay, if you look back this slide, okay, you want this answer only, okay, the total, the average, and this one. But the program give this one. Okay, so why something like this happen? It will show multiple value. Okay, so you have to detect what is the problem. So if you can see here, okay, let me show the slide. Okay, this is the example I showed before. Okay, invalid. Okay, missing missing the bracket. Okay, this one also I already show you the error. Okay, if the forget to the bracket, this one, forget this one and this one. Okay, then the next example I show you the error caused by the metric size. So add the star. Okay, the star have to be replaced. So now you see yeah, this one also I show you before. It has vector and you have a vector. Okay, vertical vector. So basically you cannot multiply normally. So you have to use a array operation. So this one already show you before. But the problem right now is this one, logic error. Your coding is run perfectly. Okay, you can run it, but the problem you get many answer. Okay. So what happened is actually, okay, when you run this, let me put a breakpoint before printing. Okay, run this. Okay, when you run this, you get W also multiple answer. Okay, and P average, you can see here, W has multiple answer. Okay, this one has multiple answer, but you use sum. Okay, you use sum, then it will be okay. So you can see here, P also multiple answer. Okay, so as the result, okay, remember back the input output. If you have multiple answer here, it will produce multiple output. So how to repair this? Okay, instead of using the array, okay, the array operation, you use metric operation. So to get the total sum of the sum of the W. So how to do that is basically you have to transpose. So transpose is basically this. So for example, you have P is something like this. So P transpose is something here. Okay, you just use this. Okay, when you do that automatically, so let me quit debugging first and run again. So I run this again, you can see that instead of multiple value of W, you get only one. So then you can run the formula and you get the answer. Okay, that is how you debug a program. Okay, it's not a step-by-step procedure. A clear procedure is basically some things like try and error. Okay, you try this, the MATLAB said something, then you repair it. But if MATLAB can run all the program, the answer is still wrong. There's something wrong with the logic. Okay, so you have to check the logic back. Okay, and for this case, don't have any round error. Okay, so make sure you try this, the case study, example 8.7 until 8.10. Okay, try to repair the program. Okay, so you have this original program, make sure you know how to repair it. Okay, so that's it for today. So today class is very short. So any question before I end the class? Okay, if no question, I will end the
Just a small question. For the
Yes.
exercise, do we submit it after we fix the errors?
What?
For the exercise tutorials, do we
Okay.
submit it after fixing the errors?
Oh, you just show the. Wait, so you have the output, right? You just print it, right? Print the common window. Show that your already try to get the error. Okay, you get the error and then you repair it. Okay, with the
So
next.
I do it twice, like one with the error and one after fixing it.
Yes, correct.
Okay. Thank you, doctor.
Okay, okay. Okay, any more question? Okay, if no, I will end the class. So see you next Wednesday. Okay, thank you.
Thank you, Doctor.
Thank you, Doctor.
Okay, welcome.
Thank you, Doctor.
Welcome.
Thank you, doctor.